Welcome, dear cloud developers, to another episode of the Cloud Builders. Today, our topic is cloud native, and we gathered industry best specialists in that topic to present for you and to answer your questions. My name is Maxim Salnikov. I work as developer engagement lead in Microsoft in Norway, and I'm here today to be event host and to be a host during our upcoming fireside chats. Why do we have this interactive part as a obligatory part of Cloud Builders every time? Because we want this event to be interactive as much as possible. So we want to answer your questions. We want to solve your problems, your issues. This is why we call it build up, bring your own problem, and ask me anything, ask us anything. And by the way, thank you very much for the questions you sent us during registration to the event. We have a bunch of them, some dozens of them, and we picked the best ones, like the most general ones, and the ones that might be useful for majority of the cloud developers. So stay tuned, we'll take them during our fireside chats. At the same time, keep the flow of questions coming, because yes, we want to interact with you, and we'll keep an eye on the comments list on YouTube and Facebook translation streaming. So just ask your questions, let us solve your problem related to cloud and cloud native, to be precise for today's event. So on our today's agenda, technical session. We start from this in just a couple of minutes, and 2 fireside chats. We invited folks from companies Microsoft, Cloud Native Computing Foundation, and Red Hat. During our preliminary discussions, we realized that there are so many topics that are really hot and trending these days. So stay tuned, stay with us. Saying this, it's my pleasure to invite our first technical speaker to the virtual stage. Mark, welcome. Please turn on your camera and microphone. Good to see you.
Hi, fantastic to be here. Nice to see you, everyone.
Yeah, so I believe it's morning in your time zone, right? And evening.
It is. Yes, yeah. I'm based in Seattle here. It's in the morning. I've just got up. Actually, this is my 3rd call for the day.
Not that bad. Yes, you're productive. 3rd call from the morning. So first, Mark is my colleague. We both work in Microsoft, and he's a leader in building innovating computing platforms with a special passion to the distributed systems that meet needs of all organizations. Mark has deep experience building technical strategies, running product teams, and engaging with all developers to have fun and to write the code. So what will you tell us today, Mark?
Well, today I'm going to talk to you about building distributed applications. And I'm going to focus on a platform that we've built over the last year, which is an open source platform. It's very much open source driven, called Distributed Application Runtime. And we call it Dapper for short. And so I was going to give you a little bit of an overview about the landscape of cloud native developers. What are some of the hard problems we run into? And then show you a demo of what Dapper can do for you. And hopefully you'll, at the end of this, take away the fact that it will help ease the way that you build these applications today.
Awesome, awesome. I heard that just a few days ago, Dapper gets to release candidate, right? Am I correct?
Yes, so Dapper was built as an open source project, and we released this in October 2019. And over the last year, hundreds of the community developers have been contributing to it all. We have over 700 external contributors to the project itself. We've actually got it into production in many companies. They've been running it now for several months, and we're on a path to release this runtime called Dapper beginning of next year. So it's on a 1.0 path, which is very exciting because it's shown that it's matured now over the last year.
Amazing. I'm super excited, and I'm super eager to hear more about Dapper. So Mark, the stage is yours. Run.
All right, thank you. Fantastic. Well, I'm going to share my screen here. Let me just Okay, there. Can you see my slide?
Yes.
Perfect. So let me talk to you about building distributed applications. Let me talk to you about what Dapper is. Dapper stands for Distributed Application Runtime. My name is Mark Fussell. Feel free to reach out to me either on my Twitter handle or my Microsoft email inside there. Love to hear from you. And I'll talk to you about the end, how you can join more into the community that we're having around this discussion. What I see today, though, is that, we talk about what cloud native developers are. And cloud native developers, are all about building these large scale distributed applications, services effectively. And that's happening because these services allow you to be flexible, allow you to be cost efficient, allow you to do easy upgrades. But of course, they're hard to build. So the path to get there is hard, but the benefits are great. And generally, we see a lot of developers, they want to focus on building the applications themselves and not infrastructure. And so the problem today is that people say, here's Kubernetes, but Kubernetes is an infrastructure thing. It doesn't help you build the applications. The applications that we see built are a wide variety of stuff. Many people want to come with their existing skills, whether that's a language like Java or C# or Go or Node or PHP. And so we see the wide variety of different tools, different runtimes for building these applications. They're very polyglot in nature in terms of how they get built. So the right tool for the right job. So that's what we see in terms of the cloud native developer landscape. And you might build an application that looks something like this. It has this is an e-commerce application, has a front-end service. It has a shopping cart. Some things are stateless, some things are stateful. You push things into state stores. You may have messages from external systems. So this is the sort of application we're sort of talking about. The problem is it's hard and there are things that are holding things back. What we find is that developers ask to build these distributed systems concepts. If I want to call from one service to another and discover it, how do I do that? If I want to do diagnostics at runtime, how do I do easy diagnostics? How do I do an eventing-based system where I send sub events between each other? And so the tools to build this are kind of fairly limited, or they're very distributed, or they're very fractured, I should say. Or you're told to you have to completely use my runtime. You have to throw away your existing code, take up a new platform and re-engineer it all from the beginning. It's not incrementally adoptable. So we want to make sure that we start from where the code is where you are today, you want to bring forward. And then often at times is that we find that it only runs on particular platforms. It will only run on the cloud. It won't run on the edge. It'll only run on Kubernetes. It won't run on my local machine. And so the portability of your code becomes difficult as well. So these problems are the things that we're also trying to solve when we built out Dapper. So Dapper is a distributed application runtime that makes it easy for you to build these event-driven distributed applications. And you can go to dapper.io to get started and find out more inside there. But I'm going to show you a demo of what that's like. So the value props is that we took all our experience of building large-scale distributed services ourselves, and we codified it into a set of building blocks that we give to you as a developer to say, take these from any language or any framework of your choice. You can use them all. They're based upon consistent portable APIs that you can call from any language or framework. We adopt standards like OpenTelemetry, HTTP, gRPC, cloud events, so that it's very standards orientated. And importantly, make this pluggable so that you can plug in other components, whether you want to integrate with other cloud providers. And it's not just an Azure-based system. It'll run on AWS. It'll run on GCP. You can plug in components to the other multi-cloud. You can plug in components to other external systems and make sure that your code is portable across different environments. And it's very, very driven by the community. A big open source project. It's grown massively in the last year. We've had thousands of GitHub stars, and we're seeing that lots of people are jumping on this project. What you get with Dapper is you get these building blocks, things like service-to-service invocation. How do I call from my front-end service to my back-end service, or between my shopping cart and my other service? How do I store state easily? How do I publish messages? And These are exposed by HTTP or gRPC APIs, and then you can write any application code of your choice to interact with these to give you superpowers as a developer to build these applications. And you can come at it whether you're a Go developer or Python developer or Java or .NET. Not only just kind of doing HTTP calls, but also you can actually take advantage of SDKs that are first-class languages for each one of those particular developer or languages. So if you're a .NET developer and you want to have a .NET SDK, you can use that to call down onto these building blocks that help you build these distributed applications with ease. And like, let's take one example of secrets. We saw so many developers struggle with getting hold of a secret from a secret store in order to talk to a backend database. We turned that into a general purpose building block that makes it easy for you to get hold of secrets or to call between your services inside there. So this all runs on top of any infrastructure. I'm going to show you today running on top of a local machine and on top of Kubernetes. And I'm going to walk through some of these building blocks. I'm not going to have a chance to do all of them, but go inside the quick starts and you can find out how all these building blocks help you build these distributed applications. But let me show you a little demo to kind of get your idea about how Dapper works. And what I'm going to do is I'm going to have a very simple application. I'm going to have a Python application that's going to send some orders to a Node application over here. And I'm going to use Dapper to do all the heavy lifting of calling onto this other application and saving its state to make it a reliable, resilient application that recovers from failures. So by showing this little demo, hopefully you can see how easy it is to use Dapper. So let me switch over here a moment to VS Code. So you'll see inside here, I have this is my Python application. And my Python application sends out order requests. And you see here that all I have to do is I post an order request. But Dapper is super easy to use because all I have to do is when I launch Dapper is I launch this as a sidecar process to my application itself. And as a developer, I can take advantage of the invoke capabilities to say, I want to call on the Node application and I want to call a new order method. So this is all I have to do as a developer. I just have to do a local host call. And now when I call onto this particular endpoint inside here, Dapper will say, take this particular API call, go and discover the Node application that's running and call a new order method on top of it. So if I go and look at the Node application inside here, you see that this Node application, there's nothing particularly special about it all. I don't have to pull in any libraries. I'm just writing this as a straightforward Node application, using Express. You see I have some endpoints inside here. And you'll see here, here's the new order method that I call. And I receive my new order method. I take the data that was sent from that Python application, which is the order and the data here. And so now you see that I've called from one service to another, and I'll show you this in operation. But in this new order application, I'm going to store and keep this data in a state store. And so here now, all I have to do is I call on to a state endpoint here. And you'll see that this state endpoint is in a similar way that I saw with the service invocation. I can just say, I want to store this into a state store name in the state endpoint. So from a developer perspective, then I just call localhost, name of my state store, and say save this state. And in this particular case, my state store that I'm using and where I'm saving all my state to is Redis. So what I can do is to set this all up and to see where my state is actually stored, I can actually put this into a Redis state store. And this state store name here now is, if I just open up my Redis state store here, you'll see that this state store name here is defined as a component. And all I do here is I say, here's my configuration to store this into a Redis state store. I set up some password information and I can easily put all my data inside this state store. So let's see this all in operation and see how this all works. So I've got some consoles down here. In order to use Dapper, there's a Dapper, I can install the Dapper CLI on my machine. The Dapper CLI allows me as a local developer to take advantage of using Dapper. Here's the Dapper CLI, take advantage of doing things like initializing Dapper onto my local machine. And I can use this Dapper sort of run command. So if you want to set up Dapper on your machine, you simply do that Dapper init. it installs Dapper locally. It also sets up a development environment. So I actually have running here locally, I've got my Redis state store. I've got actually also Zipkin in order to do some diagnostics capture. And so Dapper init sets me up ready to go. So here I am. I'm going to now run this Python application here first. So what I'm going to do is I can take advantage of a Dapper run command. Actually, I'm going to launch my Node application first here. So my Dapper run command here launches this app here, my Node application. This is this app.js here. I'm going to run this app.js application, and I'm going to launch it on a particular port here. So this is the application port I'm going to run it on. So when I run my application here with Dapper run, it launches my application. It launches Dapper as a sidecar. And now here it is my application simply running there using Dapper to do all the heavy lifting to be called. I'm now going to switch over to another command line here, and I'm going to launch, in this case, I'm going to launch my Python application. So this is the Python one here. And I'm going to use the Dapper run command here again to launch this as a Python application. And so now the Python application will launch. The Python application is sending lots and lots of messages. And what you'll see now is if I return back to my Node application, all of these messages are being received. And I'm persisting all of this state inside the state store that I've chosen to be Redis. So you'll see two very important things here. All I had to do as a developer was say, I wanted to call from my Python application to my Node application, and Dapper took care of all the problems of discovering that, finding out where it was, and then storing all that state into a Redis state store. I've got this Explorer here that allows me to look at these orders as they come in, and you'll see that the order information here is stored into my Redis state store here. And so as I refresh my orders here, you'll see that the state is being pushed in here as a sort of a key value pair. And this is super important because now if my application was to crash and come back up again, I can recover this state. I can use this to store things like a shopping cart information or a workflow state or the game session state around this thing. So this is kind of two of the building blocks that I've shown you. But what's more is that Dapper provides you out of the box diagnostics. So I can actually capture all this information, and I have Zipkin running locally. And so if I now go off and open up a local endpoint here, you'll see that all the calls between my services are being captured by Dapper. If I go and look at my local endpoint here, which is Zipkin endpoint capturing that information, I can actually go and see the dependencies and do this dependency view. You'll see now that all the calls between my Python application here to my Node application, all of this is being traced for me, it's being captured for me, it's being put into my diagnostics tool of my choice. I can go off and look at these queries a little bit more specifically here. You'll see that this is the call from the Python to the Node application here. And I can actually see the details of the call itself. I can see the time it takes. I can see the name of the method here that's being called, the new order method. So I didn't have to do anything to get diagnostics around all of this. But let's do the next stage to this application. Let's just stop this application here. I'm going to take this exactly the same application now, and I'm going to move it into Kubernetes with no code changes. So instead now I have a Kubernetes cluster here set up. And inside this Kubernetes cluster here, I have Dapper running as part of its environment. I've also deployed Zipkin to capture all the information. I've deployed Redis inside this Kubernetes cluster, and you'll see that I've deployed the Node and the Python applications here. And all I had to do was take the same code, build it into a container, and then in a Kubernetes deployment file inside here, I had to describe my Kubernetes deployment. I described it that here's my Node application that got deployed, which is this Node application that gets run inside down here. I built this into a container image. And now rather than using the CLI to launch it all, I use these annotations inside Kubernetes to say, launch this application as a Node application. Here's the application port it's running on in order to get the same capability, functionality running inside a Kubernetes environment. So if I go off and I apply these, this this manifest here into my Kubernetes environment. You'll see I'll get my Node application running inside here. And the same thing I've done with my Python application. This is my Python application also deployed inside the same Kubernetes environment. Again, I had to do no code changes here. All I did was build this out into a new image and deploy this into this environment. So now I can actually go and see, this application running. I actually have if I go back here, if I do get service, you'll see that I actually have, an endpoint set up for my Node application here. This is this endpoint. So actually you can call into it. You can actually see that these Dapper sidecars are running next to my application, giving it all the heavy lifting functionality around here. So now I can take this application, I can go off into my browser. I can actually open up and look at the order inside here. And you see that the same orders that I saw before that are being sent from my Python application are being sent to my Node application. So I could develop locally, I could deploy to Kubernetes without any code changes. And I can also get the same diagnostics environment inside here. So if I return back to my Kubernetes environment inside here, I could actually do a port forwarding on my local environment inside here. I can grab the port forward. So let me just grab a port forwarding command here a moment. If I just go down and want to pull up a particular script inside here a moment, which I was just, if I pull up this port forwarding, I'll just launch up a new window inside here. So if I now do a port forward from my local machine and I port forward from my local machine port 9412 into my Kubernetes cluster inside here, you'll see now that I will be able to return, and if I go and look at port 9412 inside here, I'll launch now Zipkin running inside my Kubernetes environment. And in the same way I did it locally, I can look at the traces inside here, I can do the calls. I see the same calls now looking inside a Kubernetes environment for the same diagnostics. I can see the same. If I go and look at the trace call inside here and run the same query here, you'll see here's my traces I just did from a few seconds ago. I can show the same calls now, which has on my new order application, but this time deployed inside Kubernetes environment with the same diagnostics. So what was cool about this was that I did all the heavy lifting of making sure that I could call onto my remote application. I could save my state inside here. If I go back to my calls, you'll see that I can actually go back and see that there are state store calls inside here where my state store gets saved as well. So I can see the time it takes to store my state inside my state store without having to do any code changes. So hopefully that's given you some idea of the capabilities of Dapper, that it's very easy to build out these distributed applications. What's more is if I am a particular developer from a particular language, I've now switched over to Visual Studio here, and inside Visual Studio we can actually bring in, or inside the language of your choice, you can choose to bring in client libraries instead, which provide you a more language specific experience. So you don't have to just do everything over HTTP. So say I'm a .NET developer, I can actually now do client dot, and you can see here, the client builder here returns me a client class, and all the same API calls that I had just calling over HTTP are first classed here in terms of sort of getting the state, invoking other methods, saving state inside here as a sort of first class experience inside my development environment inside here. So you can do this with Go SDKs, Java SDKs, .NET SDKs, Python SDKs, if you're a particular language that you want to build these things in. So let me just switch back to slides here a moment. I realize I'm kind of getting close to time because I want to take a few questions. So in the end, when you build these sort of cloud native applications on top of Kubernetes, and you want to have an abstraction where you can build these very easily, but you want to push all your diagnostics, say, into a diagnostic store of your choice, or take advantage of all these secret stores of your choice. This is sort of the application that you build. And the key that Dapper provides is that when you build this application inside here, you can plug in all of these different types of components. So I showed you a Redis state store, but if I want to plug in AWS DynamoDB or Cosmos DB or Cassandra or Firebase, there are many, many different types of state stores. Or if I want triggers from external systems, like a message to come in and trigger my code from Event Hub or Kafka Q, I can. Or if I want to do an event from one server here to another, I can take advantage of NAT server or RabbitMQ. And this makes it very powerful for you to be able to take advantage of building Dapper, but defer the technology you're going to use. And the community has been amazing over the last year, contributing all these different types of state stores, pub sub mechanisms, how I integrate with external secret stores, how I trigger with external systems such as messages from AWS simple notification service or Azure Signal R or just general MQTT message brokers for integrating Dapper into other systems. And this is where the community has helped us a lot, and this is where there's been a rapid uptake of Dapper. And in the end, it comes down and solves these hard problems such as service invocation between your Python and your Node application with simple API calls that solve all of the distributed systems problems that users shouldn't have to take hold of. And it does that with easy diagnostics, with things like open telemetry to plug into systems here. That's another key aspect to it. I've only just touched on what that does with two things. There are many more things that you can do with Dapper in terms of trying out these building blocks. I encourage you to go to our docs website here, docs.dapper.io, where you can actually go here, try out the Getting Started guide here. This is the Getting Started guide of how to install Dapper here, set it up on your local environment, configure it on Kubernetes, and then you can go and try out a whole collection of quick start samples. I showed you this one here today, which is Hello World, but you can try out ones that take advantage of all the other capabilities of Dapper inside here, and effectively make you as a developer not have to solve these distributed systems problems, but make you as a developer have superpowers so that you can actually build the applications that you need to build and focus on your business logic, where Dapper takes care of all the hard problems that you shouldn't have to handle when building on platforms like Kubernetes. I will leave back on this slide here a moment, and I have a chance here now to take some questions.
Thank you very much, Mark. Very inspiring story, and I really can't wait to try Dapper in action myself. To be honest, I follow this project, but never did anything hands-on. And just help me with that. So you partially answered my first question, how to start with Dapper. So there are quick starts, and I believe short and very practical articles, or I don't know, guides how to do this. But let's just imagine some scenarios. I'm full stack developer.
Yes.
I create my application with let's say front end written in JavaScript or TypeScript and backend in Node.js. And this is actually a family of services, so we can call this microservices. So one service written in Node.js doing that, and second is doing that. And I want to test everything on my local machine. Let's say this is Windows laptop. How do I start with Dapper? Like literally step 1, step 2, step 3 to help our dear attendees to start.
Okay, all right. Well, if well, to get started, you can go to our Getting Started guide. Can I reshare my screen again?
Yeah, please.
Yes. So let me just share my screen again inside here on what that actually looks like. So if I just, what are the steps in order to do that? Yeah, you literally can go here to this Getting Started guide here. So step 1 here, I'm wanting to build this application. Go install a Dapper CLI. if I'm on a Windows machine, you can literally take this PowerShell script inside here. If I'm on a Linux machine, you can take this Bash script inside here, or a Mac OS, you can take this curl here. I literally then go into launch a command line prompt inside here. Paste this paste this whatever the script inside here, and this installs Dapper on my local machine here. So then I start off with Dapper, and I have basically the Dapper CLI installed inside here. After that, you literally do Dapper init like this, and Dapper init will now configure Dapper on my local machine. It says I've already got it installed, so I'd have to install it first. This sets up my local development environment. At that point, now I've got Dapper installed. You can now go off and try out some of our quick starts. It's usually useful to set up a Redis state store if you want to, but actually this gets pre-configured for you. So when you set up Dapper init inside this, you'll see that a state store for you has already been set up in order for you to take advantage of storing some state locally. So we set up this whole environment for you. The next step is you literally can go in and you can set up some more things about your development environment. Say you want to pull down VS Code or IntelliJ. We don't mind what you use. There's actually a VS Code plugin if you want to use Dapper in VS Code. In fact, if I go back to my VS Code plugin here, we actually have a Dapper plugin that you can take advantage of here that actually allows me to do debugging with Dapper inside VS Code. And then it's off to the quick starts. Go to the Hello World quick start here. I showed you walkthroughs Hello World quick start here. You can go through here and it'll walk you through everything from cloning the repo to building out all of this. So that's how you get started with it all. If I now want to build that application, what I would do is I could go in and start to, look at the quick starts, understand how those work. You had a front-end application build onto my back-end application. Effectively, we don't have any template generation just yet. So, the template generation is coming, something in the future. So right now, what you'd have to do is effectively just be, a VS Code developer. You'd use the VS Code tools to say build out my node application like this. So I just build my application just as I would do as a normal development experience inside here. But all I take advantage of is, the building out calls like this onto Dapper, where I do these local host calls, and then taking advantage of the Dapper CLI commands to run it here locally. So now here I do Dapper run, and just like I showed you before here, this Dapper run allows me to develop locally. Outside of that, you have the same debugging experience, the same development experience you had with whatever your development environment is. Mm-hmm. So hopefully that answers your question.
Yes, totally. It's this will take literally a few minutes for you to start with Dapper. So I encourage our dear attendees to try this today. And I really love that there is a plugin for everything in VS Code. So
yes,
a really amazing ecosystem. Now we have everything running locally. Time comes to push everything to the cloud. What can we do there? And so I really feel that Dapper should be part of every public cloud infrastructure as a managed service, because it's that important component. So what are your thoughts on this one?
Well, so first to install Dapper on your Kubernetes environment, I'll share my screen here again. Let me kind of just go back here and just go back to share my screen and share this. So if I want to install Dapper on a Kubernetes environment and what that all looks like, you can actually do this two ways. You can actually do Dapper. So here I have a particular Kubernetes cluster context set up on my machine. I have actually, I think you'll see inside. I can see here that I have Kubernetes deployed inside here. I can actually do Dapper init -k like this, and just using the -k option, it installs Dapper onto my Kubernetes cluster that I've set up as my local context experience. And so if you actually go and do, you'll see that inside here, that if I look at, if I go and look at the namespaces inside this cluster that I have set up, Actually, I should just do get namespace. You'll see that I have a Dapper system inside here. So if I do get the pods inside this particular namespace, Dapper system, like this, you'll see that this is the control plane here for Dapper running in highly availability mode, which is production mode on my local Kubernetes cluster. But to install this, it was as simple as doing Dapper init-k. There's Helm charts that you can do to all of this. Now, this will apply to any Kubernetes environment. This will run on Minikube. This will run on AKS. This will run on a raw Kubernetes deployment. This will run on Google Kubernetes environment. This will run on AWS Elastic Kubernetes service. It'll run on any Kubernetes environment that you've set up and configured inside this. But Dapper will actually also deploy onto other environments, not just Kubernetes. It will run on any other environments. So that's how you kind of get up and running. Now, to answer your question, where are we taking this so that has a first-class experience? We're certainly on a roadmap where we want to make sure that not only do you have this experience easy to deploy inside your Kubernetes environment just by this script, but would love to see it built into a first-class experience such as the Azure Kubernetes service, where you can go up there and you can just go into the AZ AKS command inside here like this, which allows me to see a list of my AKS clusters and have this as a first-class experience where I can deploy Dapper into this environment. But this is, this is something that's on the roadmap. It's certainly something that we want to make sure that's a easy experience for you to do. But getting Dapper installed in a Kubernetes experience is very easy today. But certainly there's a roadmap where getting Dapper into many of the cloud services is a direction that we see going.
Awesome. So that means that sooner or later we'll have sort of managed Dapper service on the public clouds, right? So that's the roadmap.
That's the direction we'd like to go. Yes, I haven't got anything to say on that just yet, but let's just say build next year will be an amazing time.
Cool. Yeah, we have a couple of minutes left, and my next question is like in another scenario. Now imagine I'm a developer of interesting open source product. Let's say this is some form of database. How do I write a connector to Dapper so folks can use my product within Dapper?
Great question. Yes. Yeah. Let me go back and let me just share my screen here again. One thing I didn't point out before is that it's very easy for you to be able to switch over different environments. So you saw here in my Node application here that I was saving things into a state store name. Now, this state store name I showed you here was a Redis state store. So here it was just Redis state store. But say as a developer, I wanted to switch this and say I didn't want to change any of my code here, but I wanted to store this into Cosmos DB. You'll see that this state store name here, I can now create a Cosmos DB plugin for this. This is a component model where the state store name is exactly the same, but this time instead of using Redis state store, I use Cosmos DB, and I provided all the credentials inside here. So if I was to put in the key information inside here, which I don't have set up right now, I could run exactly the same demo I showed you just now, but now we will be storing all of my data for my application into Cosmos DB. Now, the question is, well, how would I provide any other state store around all of that? The answer is that if you go off to GitHub, where we have all of our Dapper repo, go to GitHub here. This is the repo that we have with the Dapper repository. This is actually where we have all the quick starts inside here, where you can try them all out. I just showed you. So this is the list of all the quick starts inside here. But that component model you build and deploy is all inside this repo here, contrib. And this is where the community has added and helped enormously. So here, I go into the component contrib here. You'll see that there's some documentation here that tells you how you develop a component plugin. So this tells you exactly how you should write a component for Dapper, how you can write a component for state or pub sub, how you do the building, how you validate it all. And if you go through this, this will help you write the components. Now, what it comes down to is, say I wanted to write a new state component. These are all the state stores we have today. You'll see that there's this Azure state store inside here. You'll see here's this Redis one. But say, for example, we had a community write a GCP Firestore plugin where I save all my state into the Google Firestore. What you effectively have is that you have an interface definition. So to write a new state store here, this is the interface definition that you implement in your code. You'll see there's an initialization, how I do get requests, how do I do delete requests, how do I do set requests into my underlying state store itself. So by implementing this interface definition here, and if it's a transaction state store, this definition, you implement this in Go in your, onto your favorite state store. So for example, say it's MongoDB, you'll see inside here that this is the Go implementation of the interface that we saw inside here. For MongoDB, it implements that interface inside here and pulls in the Mongo libraries for this, and basically does the abstraction on top of that to storing data inside your MongoDB database. So it's very simple to write these things, add a new state store or a pub sub mechanism around all of this, and you'll see that this isn't a huge amount of code. It's usually abstracting away the underlying MongoDB libraries in order for you to be able to implement your own component type. And then you can publish it into the components contrib. We'll get it all up, and we'd love nothing more than people contribute new secret stores, there's new secret stores here for like GCP or Azure Key Vault, HashiCorp. We worked with HashiCorp to do Vault inside here, or new components for external bindings, which is triggers from other systems around these things, whether that's things inside Ali Cloud or AWS or GCP, or just general bindings like having a RabbitMQ message trigger my code. So I hope that answers your question.
Yes, totally. Thank you very much. So as a summary, folks, if you drive some open source project which is applicable to microservices, to cloud native, create a plugin for Dapper, and you will increase your user database quite significantly when more and more developers start adopting Dapper, and this will definitely happen. And I really love that this project is so well documented, so well equipped with all the quick starts, templates, and SDKs. Great job, Mark, and community.
And the thing I really want to stress is this open source. Like everything is open source, and importantly, there's an open governance model as well. So we're trying to make sure that Dapper is on a path where we have now about 15 or 16 external approvers and maintainers who are actually maintaining the Dapper project itself. So we really want to encourage you to become an improver or a maintainer of the Dapper repos inside here. We have now over 600 external contributors from a wide variety of different companies who are contributing to the project. Just yesterday, we're having to go through 19 pull requests from the community for adding new features around here. There's a big, vibrant community, which we've just moving over to Discord as the community environment. And we want this to be eventually taken into a standards body, something like CNCF, and to be open governed, and to kind of not really just be driven by any one particular company, but to be owned as a community distributed systems environment that can be contributed in many different ways, whether you're adding just a new component or a whole new building block or making this run on top of a different platform. We've had people ask us, how does it run on top of Docker Swarm or Mesosphere or OpenShift and things like this. So yes, please come and join the community, and we're very open to any form of contribution.
Thanks, Mark. Great story, great project. Have a great day.
Thank you very much. Thank you, everyone.
Okay, folks, we continue our program, and without any delay, I would like to invite our special guest for a quick interview. So, please, Roman, welcome to our virtual stage. Are you here with us? So, yeah, welcome back to Cloud Builders episode 3. And our special guest today is Roman Pavlyuk. Roman has more than 17 years of experience in informational technologies, and he has strong experience in leading IT consulting and advisory practices and delivering high value services. Currently, Roman is VP Technology in the company, which is leading in technology, IT advisory, and excellence company called Intellias. Welcome, Roman.
Hey, hello, Maxim. Really glad being here back again because I've been to this session, I don't know, a couple sessions ago, and it was very cool, very nice. So really happy to be here talking to you, and really happy to be talking to our listeners today and viewers, I guess, because you have a live picture now.
Do you want to share a couple of words about your company? What are you doing?
Sure. Well, I'm VP Technology, basically acting as a CTO in Intellias. So the whole idea is that I'm running the organization that is called Technology Office. Technology Office's main goal is to breed, develop, organize the excellence in the company, and excellence for those people who do the major part, which is, Steve Ballmer was saying, like, developers. You probably still remember this very nice video. I'm watching this all, like, every other day, to be honest, because it's so inspiring. But the next thing is we also care about the advisory and consultancy expertise. But when I'm talking about consultancy, it's not the classic one. And then when you come to the company, like those, okay, I will not use any other logos in this session, but like they give you this giant report and they charge you for the $1 million, which is still valuable because they share the very brilliant ideas. I used to work with them as well. So very cool experience. But we do this as an advisory mode when we really design, think, ideate with our partners and clients. We narrow the solution. We help to productize it. We care about the productization, so we go with them all along the way up until they basically start monetizing and getting the benefits, and even all the way there up to the product sunset. So that's the whole point. And this is about bringing this constant extra value expertise. That's why we have people like, of course, solution architects, solution designers, product managers, different kind of data engineering and data science people who really care about the data, like experience design, because experience is one of the most important things in this whole chain, and as well as the security folks who basically help us making this all secure. So, as I said, all set of services that help us to breed this excellence, keep it in place, and always deliver extra value to our partners and clients.
Yeah, that's a very good word, excellence. And all
Love
the
it.
IT projects should be excellent to deliver with so high demands we have for current projects. And what I see on the market of IT products last 2-3 years, the complexity of these projects is growing, so they become more and more comprehensive, and their solutions are now, I don't know, bunch of logotypes mixed all together with multiple errors in between. So what could you say about that one, about growing complexity?
Mm-hmm. Well, you see, applications are playing bigger and bigger role in our life, and this is the exponential growth. Like, you have now at your phone, which is like complete phone banking. I mean, like you have like all digital banks, which is basically software is taking care of your money, which is critical because if it's buggy or if it's poorly designed, you're going to be living on the street after some time. Software is managing your time. It's managing what you eat, how you sleep. Basically, it's like it's managing your life. So so those things that we used to have 10 years ago as a nice to have, they became mission critical to our life. I'm not even talking about the business life. I'm talking about personal life. So if we do have the poorly designed software, if you have a poorly designed solutions, the impact is major. That's why the load on the specialists, the load on the experts that do design this software is significantly higher, and it gets bigger and bigger, right? So that's why this timeline, when you take like 5 years ago and 10 years ago, I don't know how about you, but I used to design like cloud software usually for B2B solutions, like mostly. Now, like it's mainly B2C, and this is the critical thing. So it has to be well thought, very well designed, and it has to be very reliable. So, and it has to be also maintainable and easy adaptable to the changes. So it's like you have to build a very flexible architectures that's at very like little cost. In a very short term, you should be able to add more and more features. And because that's what the market wants. Like today, one company is releasing some extra feature. I don't know, like some like NF, like this near field proximity payments or whatever, and then tomorrow everyone should have it. Everyone should have it, despite are you ready for this or not? You should have it. That's why you better be ready. That's why your architecture has to be very scalable and very well thought and adaptable for the changes.
Yep. So with this growing complexity, we definitely need more very skilled solution architects, or even to be more precise, cloud solution architects. So what are your thoughts about cloud architect career? Where do you find cloud architects for Intellias? Do you grow them up internally? And just inspire folks to have cloud architect career?
That's a very good question. You know what? I could have a simple answer, like we just tell them that we need them and they come. But unfortunately, not. It's not like this. So it's like I compare this to like teaching a pilot. I would say even this like a spaceship pilot. Like to become a cosmonaut or astronaut, depending which country you are in, it's complexity. So you become like a trainee pilot, then a pilot, then you become a cosmonaut, and then you actually go to space because you pilot something extremely major. That's why the same here. So that's why we have like tech leads, we have application architects, we have senior application architects, we have solution architects, and then we have this whole program that is developing people throughout this. So we created the culture, we created the process where there's a strong demand in those people. There's there's always a place for creativity. So because the process of creating this modern software always creates the place for people, for the creative people, for people who are like very design thinking oriented, to basically express themselves. So we tend to have like even more focus on this. So for example, we say, okay, we're building the complex software. We challenge our associates, hey, can you like come and do it? I mean, really, come and do it. And when I'm talking to different people in the company or even like outside the company on the market, saying like, hey, would you like to join us to have something like extremely complicated to be done? And they love it and they say, yes, that's what I want to do. So people are not, I mean, you could have been thinking that people might be scared about the complexity. They are challenged by the complexity and they're inspired by the complexity. So that's the way we do. So we give our people more and more complex tasks. They grow, they make mistakes, which is fine. I mean, I wouldn't believe in the people who will not make mistakes. So they grow, they get better and better and better. So, and they reach that stage when they are named, hey, I'm a solution architect. So I'm that level of expert.
Awesome. Thank you very much, Roman. So folks, if you wish to build your way to become professional, skilled cloud solution architect, contact Roman. Just last super quick question. Do you accept remote work?
Oh, absolutely. I mean, it's a 2020 can be unfortunate or fortunate for some different reasons. Well, let's not discuss this right now. We all know what's happening around us, but remote work is the thing to go. So it's even like usually it's a question people ask me, like how does the life of solution architect in Intellias looks like? It's when you deal with lots of challenges at the same time, and you might be in a different location. Moreover, I know there's a challenges on travel right now, but it will not last like this forever. And I wish you're gonna be not only in multiple challenges. I wish you will be at the multiple location at the same time. So it's not that you are not like nothing important happens in the office. If probably you know that Nihito statement, like nothing important happens in the office. We say the same here. So you go, you work in the client locations, you work in different offices of our company, which is because we are getting global. You work in different locations that you might prefer, of course, and that's how your life looks like, and this is how your professional life looks like, because you work on the multiple challenges at the same time.
The best ever question I expected to hear. Thank you very much, Roman. Have a great day.
Thank you, Maxim. Take care.
Okay, folks, let's continue with our program. And our next guest is Cheryl Hang from Cloud Native Computing Foundation. And let's invite her to the screen. We are on air. Hello, 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 Cheryl. Nice to see you in our virtual studio.
Hi, Maxim. Great to be here. Thank you for inviting me.
My pleasure. Cheryl Hang is VP Ecosystem at the Cloud Native Computing Foundation. So it's hard to imagine the more relevant company for our today's topic, Cloud Native, right? So this company is part of Linux Foundation and home to Kubernetes, Prometheus, Envoy, and tons of other open source projects directly related to Cloud Native. She leads CNCF end user community, the largest end user community of any open source foundation or standards body. Also, Cheryl is a frequent speaker and founder of Cloud Native London meetup. I've seen a couple of videos from this meetup, and yeah, it's full of very practical sessions inside. So I recommend you folks to find on YouTube Cloud Native London Meetup. You'll find tons of interesting information. And as C++ engineer, she previously worked on backend features of Google Maps and holds a master's in computer science from the University of Cambridge, King's College. Anything else you want to add about yourself, Cheryl?
I think you've covered it pretty well. Yeah, I've been involved in Cloud Native for quite a while now, and it is fantastic as always to meet members of the community, find out about how different people are actually implementing Cloud Native, and kind of get to the truth and the reality of it. Because sometimes it does feel like there's a lot of hype, there's a lot of movement, a lot of energy, and it's hard to know what the real truth is. So that's what I'm hoping to chat with you today about.
Yes. We'll have we have so many questions from folks who sent their questions during their registration. So I picked only a few of them because we have limited time. Actually, like only 20 minutes. But let's start. Let's start immediately. So and we start from the questions from our attendees. What could be the best monitoring tool for distributed system?
I think this is an interesting question. So let me sort of step back a little bit and say, from the point of view of CNCF, our goal is to be neutral, right? We want to host these projects and we don't want to, prioritize one over the other. And so we try not to say, okay, this is the best monitoring tool, or, you should use this tool over this one, or this vendor over this one. So instead of being able to say, okay, here is the best monitoring tool, and also what does that even mean? Because there are tons of monitoring tools. They all have different benefits, different, pros and cons. Instead, I want to say, if you're thinking about how to choose an observability tool, and here are some places you could look and some sources of information that you can use to make your own decision about this. So I hope that makes sense, because as I said, I can't just straight out answer, what is the best tool. Mm-hmm. One of the reports that I've been working on recently is called the CNCF End User Technology Radar. As Maxim, you already said, I work with the CNCF end user community. This is a group of more than 140 companies who are in finance, retail, travel, technology, a huge mix. Some very, very small, and some of the largest companies like Apple and MasterCard and whatever. And one of the goals of this report is to distill the experience from these companies and try and share it out to the world and say, what do end users really use? What do they really recommend? So each quarter we produce a different report, and as luck would have it, we produced one on observability tools in September, and you can see it at radar.cncf.io. And this report does not say use this tool, this is necessarily the best tool. Instead, it looks at some of the patterns and some of the themes. And actually, within observability, it's extremely common to see companies using 5 or 6 or 7 different tools, because it's relatively easy to add an observability tool and then to leave it. It's not like storage, right? Storage is something very big, very monolithic. If you're going to move it, you have to make a well thought out plan and mitigate the risks. So observability, it is extremely common to just adopt new tools as they come out. So I would recommend that you look at radar.cncf.io, where you can find our past reports on observability, and also we have one on database storage and one on CI/CD as well. And just read through those and then use those to help yourself figure out the best tool for you.
Fair enough. Very good answer. And I feel that we'll go back to this radar, not once during our today's fireside chat. So I think that it's really full of insights that will help folks to first start using cloud native approach, and second to make it excellent, to build more robust, more performant, and better architected applications. Let's jump to our next question we received from attendees. Maybe it also could you could also refer to Radar. What about Kubernetes alternatives for smaller projects, or maybe just Kubernetes alternative? What do you think about that one?
I would love to chat to whoever sent in this question, and I would love to ask them, what is the actual problem that you are trying to solve? Because Kubernetes is complex, right? In fact, this was one of the results that we saw from the CNCF survey, which is an annual survey that we run every year. The top most reported challenge was complexity of the solution. Kubernetes is huge. There are more than 70 projects within CNCF. And so you have to add a lot of different things on top of each other. And so it's absolutely right. For smaller projects, you may not need Kubernetes at all. You may be very happy with using, standard AWS EC2 instances, for instance. You might even be happy with using your own on-prem, a couple of boxes, because the really key point is what is the issue that you're trying to solve? Commonly, what I see from companies is, from end users, is we find it difficult to ship quickly because our release cycles are every quarter or every 6 months or once a year. And we want to get to the point where we can be doing continual releases, daily or weekly. There's too much manual effort going on. So we want to automate a lot of the typical, SRE tasks and handling the actual machines and upgrading the machines and this kind of thing. And I have just forgotten what the third one was. It's okay. I'll come back to it later. But this is why I say, like, what is your actual challenge? Because within the container orchestration space, I think it's pretty clear to say Kubernetes has won, at least on the community and the backing of the number of companies, right? I guess that's kind of why we're here and we're talking about Kubernetes, and we're not talking about some of the other alternatives that were popular a few years back, like Mesos or Docker Swarm or HashiCorp's Nomad. I would say if you're at the point today where you are at a small company and you're thinking about whether you should use Kubernetes or not, first think about what is the problem that you're trying to solve.
Yep. Very good advice. And really, understanding of small project is very different for every single use case, right? So, for example, it could be small project in terms of number of microservices within this project, but at the same time, for this small project we need 99.99999 reliability, and this small project can has to accept millions of connections per second, right? So this will be another definition of small project, and maybe in that case you need to have this full-scale Kubernetes ecosystem just for few lines of the code, right?
Exactly. And yeah, you actually just reminded me that third thing that I missed is the scalability part of it, right? If your service serves 500 users and you never expect that to grow in the future, maybe you don't need something like Kubernetes, which will add complexity to your solution.
Yep. Back to the survey you mentioned. So what kind of survey is that? How often do you hold this survey? How to participate? And most interesting, what kind of insights could you share with our dear attendees from this year's edition?
So we do run it once a year, sometimes twice a year, but most of the time once per year. And we run it around April, the actual survey itself, and the results come out a few months later. And usually we get between 1,000 and 1,500 responses. This past time we got 1,300, and that's a huge mix of companies from all over, the US, Europe, China, Asia, a huge mix of places. And the survey mostly goes to SREs and DevOps engineers, so people who are actually hands-on building it, and just ask some questions about what is the scale of what you're running, what products are you using, and what are the challenges that you see. So some of the interesting things that I think came out of the last one, well, let's start with the not interesting things, okay? Probably not surprised to find out that almost everybody uses containers now, right? The first edition, we ran it in 2016, and about 25% of attendees were using containers in production. Now, today, it's more like 96%, right? 3 years, that is not a long amount of time to see it go to that high. But again, perhaps that's not surprising to you. It's probably also not surprising to find out that Kubernetes is used heavily, and some of the other projects like Prometheus are also very widely used. I would say things that have come out that I find personally interesting. One is on stateful applications, running stateful applications within Kubernetes. This is because I come from a storage background myself. In a previous company, we were building storage for Kubernetes, the ability to run stateful applications, and in particular databases within Kubernetes. And at the time, running stateful applications was very, very hard. There were very few best practices or very few tools that would allow you to properly scale the databases to fail over between regions, and even, multi-cloud. I don't even know if it's possible now, but in a future world, like multi-cloud stateful applications, it kind of seemed very, very difficult, right? And in this survey, we found that 50% of companies are now running stateful applications within Kubernetes, which I think is pretty impressive. And it goes to show that there's a lot more products and tools that are out there now to help with running stateful applications. And then overall, on the challenges side of the world, the number one challenge that we saw, I already mentioned this, is the complexity of the solution, figuring out making the right decisions and being able to understand the trade-offs between different decisions. And the number two challenge that we saw was the cultural changes required with the development team. Maxim, maybe have you had any experience of this?
Well, I hear a lot about cultural changes in context of, for example, DevOps, right? Which is also a very natural part of what we call cloud native. And by its and widely adopted definition, culture is officially included in DevOps story, right? So totally, yes, of course, you have to change something in your mind in terms of adopting all this relatively new stuff, a relatively new way we build and distribute and monitor applications these days. Of course, for some folks, it's just like very complex to let's say break their own bubble. let's say like this. And of course, yeah, it's not only technical, it's really changing of the mindset. And this is really good that we involve this cultural part of this very technologically heavy definition, right?
Great. I do actually see in previous years, the top challenges were often the tools. It was a lack of monitoring or logging or storage or something else. So I do think it's interesting that the cultural change is now one of the number two kind of top issue. And actually, as another interesting side effect, I see now students and junior developers who have never deployed in anything other than a container, and they're so comfortable with these tools and technologies, and that can sort of be an interesting little bit of friction with the team as well, where some part of like everything should be on cloud, everything should be with containers, and then another part of the organization who's like, no, we have to maintain, whatever security standards, or we want to maintain more control. So definitely changing technology is easier than changing people.
Yes. About folks who initially start their like developer career from containers from Kubernetes, I feel that it's quite relevant to what's happening in web front end area when many junior developers, they start straight ahead from using some framework, is it Angular or React or whatever, without ever deeper learning of the foundations of JavaScript language as language. I'm not saying that it's good or bad. This is just an interesting trend, and yeah, maybe the same is happening in development in general. So you really start thinking from cloud native from day one, like we think about mobile first for example web projects, again straight from day one of your whole IT project.
It's definitely true for me as well, because I started my career at Google. Google, of course, famously has used Borg for many years. So when I started, I was young enough that, you know, to me, this is just how you build software. Like, of course, you just deploy it using a bunch of commands, and, you know, you have an SRE team who handles most of it. And actually, it was a shock for me when I left Google in 2015. And I was like, oh, turns out this is not how the whole world builds and deploys software. So for me, that was a moment of like, oh, this is quite shocking. And then since then, I guess that's why my career has kind of moved down this infrastructure path.
Folks, on Cheryl's YouTube channel, there is a really great video of her presentation about patterns and challenges of cloud native adoption. So this video includes, if I remember correctly, 3 short stories from particular companies. For example, I remember folks from one sport brand. Was it Adidas?
Adidas, yes.
Yes. So they explained their journey to cloud natives. It's a very insightful video. So you'll find lots of interesting aha moments for you and for your team. And to finalize our discussion, Cheryl, what advice, what recommendation could you give to our dear attendees for easier or painless or almost painless adoption of cloud native?
I love that you put almost painless, because as we know, like nothing is ever completely painless. There are ways to make the pain smaller. You know, you could pay a consultancy to do it for you. You can use managed services, but assuming that that's not the kind of answer that you want, I would say get involved with the community, share what you're doing and share what you know, because there will always be other people who are facing the same challenges as you, and they will be able to help you out, or you will be able to help them out, and together you can figure out the best way forwards. There is no easy sort of one size fits all path to adoption. Of course, things change so fast that even if there was a perfect path today, that's not going to be the case by 6 months from now. So I would say get involved with the community, meet other people, share what you know, just get to know people, and you'll get a lot back from it.
Great. Yes. If I have one advice on over IT technology in general, I could say rely on community, trust the community. There are lots of folks around you with exactly same challenges, and some folks they solved exactly your issue just a few minutes ago, and just find a place where to find these people. And it's not only limited to Stack Overflow, right? So there are tons of communities here and there. And yeah, so if I understand correctly, CNCF has their own gathering of communities, right?
Exactly, yeah. The one that I work most with is the end user community. So if you are adopting cloud native, if you're adopting Kubernetes, then please come and join this CNCF end user community. We have meetings, like closed private meetings just with other end users. where we discuss a different technical topic every 2 weeks, and usually 3 or 4 different companies present their solutions on this topic. So even just by being there and listening to the way that different companies solve the same problem, you can learn a lot. You can really learn a lot.
Yeah, this is excellent call to action for you folks. Join CNCF and user community. And we'll share all the links our dear speakers mentioned in the follow-up email. So stay tuned. We'll share all the resources with you. On that, thank you very much, Cheryl. Have a great evening.
Thank you so much. Take care. Bye-bye.
Bye. Okay, folks, we continue with our program, and stay tuned for our last part of the event, Fireside Chat with Daniel O. Welcome back, dear attendees, to the final part of our today's show, Cloud Builders episode 3. And I have my dear guest with me for the Fireside Chat. Daniel O, hello.
Hi, Max. Yeah, thank you for having me. Hello, everybody, and thank you for joining Fireside Chat. My name is Daniel O. I'm working for Red Hat as a technical marketing major. Yeah, a little bit more specialized cloud native stuff like application and operation and architecture, design platform, etc. Let's talk a little bit about in the next 25 minutes.
Great. We start right from the questions we received from our attendees when they registered for this event. So this will be precise technical questions. Let's start from number 1. When do we need or when we don't need to use service mesh?
Yeah, that's a really good question. And actually, I got to ask that question for last 2 years. And I participating and present in a lot of big conferences. Because, we have a lot of great super developers. I mean, Spring Boot developer, Java developer, and Golang developers. And they can take care of all application stuff, including some microservices functionality. But turns out, Kubernetes came out and the container technology came out, and a lot of some functionality moved forward to infrastructure layer. For example, smart routing or fault tolerance, and then discovery and service resiliency. These are all stuff based on implement and application side. For example, if you have a Spring Boot application, you need to add that capability into your Java code, method, classes, etc. But turns out, so the goal, ultimate goal of the microservice is a little bit more focused on single business functionality or features. And now, but after your implementation, you need to take care of a lot of the on non-functional stuff, like I said earlier, some function. I mean, the resiliency and fault tolerance, etc. So that's why the service mesh get rid of that non-functional microservice capability from your actual application code. And then how it works, Envoy sidecar, maybe Istio service mesh or Linkerd service mesh will take care of it for you instead of the application code. But for example, so my company, maybe your company has a lot of great developers, and then you don't need to use Kubernetes thing, like a big cluster, big cloud. And then you already have good software experience, development experience to manage that non-functional microservice capability. And you can go with the without service mesh. So maybe 100 microservice application running on top of just a few virtual machine, or even bare metal. Go for it without service mesh. But if you are considering, or even already, if you are running thousands of microservice application with a container and running on Kubernetes, and then maybe you need to think about adopt a service mesh. But also, the serverless and function as a service is one of the buzzword and a big trend to move for the next year cloud-native architecture. In that case, service mesh is a great benefit to integrate serverless and service mesh. So these are two use cases, whether you adopt service mesh or not.
Mm-hmm. Cool. Thank you. Very practical question. Literally like a decision guide for you folks when to go for service mesh, or you can avoid this. Before I ask the next question, just notice that we both have our mascots. You have the Red Hat, and then I have Octocat, official mascot of GitHub, a friendly company of Microsoft. Cool.
I like that.
By the way, I also have Red Hat. Got it on some conference. Yeah,
nice.
You have to find it. Let's move on. How to handle configurations for different environments using Docker containers. For example, developer wants to change app parameter from one value -42 to 42. Which steps should them take to get these changes in test environment?
Yeah, that is a really good question. It's a little bit more, I think, it's a developer perspective. You know what? So the short answer is you can use the mount capability. So when you have some configuration stuff, maybe you can mount your local file disk or storage, etc. And then you just need to change your that file in your local disk rather than inside the container. So that is maybe easy and good way, but there's a more smarter way. For example, if you are using Kubernetes, there are a lot of features to manage your configuration stuff, such as config map or secret or even persistent volume claim. And even you can use the environment variable and you attach that environment variable inside the pod. So there are multiple ways to handle your configuration rather than inside the container, which means you don't need to repackage your container image and push that thing and rerunning. So this is, I think, inner loop development, your containerized application. You don't need to worry about that. But also, recently we have a lot of great cloud-native Java application framework like Quarkus or Spring Boot, etc. They also provide unified configuration feature, which means you can just add multiple configuration with some prefix in single application file. And then you could just pass down, okay, this is a production environment, this is the development environment. When you run the container, and automatically that framework auto-wire specific configuration along with your certain environment. This is a more smarter way, maybe more prepared for developer standpoint. But the answer is there are a lot of things, but if you're just looking for the testing environment on your own local machine, yeah, just using mount capability, that's good for you, I think. Yeah.
Thanks for answering. On your YouTube channel, you have really interesting video. I watched this with a great pleasure about 6 requirements of the software to be cloud native. I think that this will be really useful for our dear attendees to hear about these 6 points from you today. Maybe let's iterate briefly through them, and maybe we'll stop on some of the points and continue our discussion from there. So, what's your take on these 6 points? What I love the most, it's all based on your experience. So it's insights from you based on what you learned from working on lots of cloud native projects.
Yeah. Thank you so much for bringing up my YouTube channel. Yeah, just a quick bringing up my YouTube channel, bit.ly URL, and bit.ly/Daniel TV. There are a lot of technical tips and a demo and tutorial, just like Max mentioned. Thanks for that again. Yeah. So I recently post one of the technical tips my YouTube channel around 6 requirements for your cloud native software. Because a lot of people, everybody is doing cloud native thing. Like, okay, we need to build a new cloud native platform based on Kubernetes or Amazon public cloud using Amazon Lambda or something EKS or ECS, etc. So, but you know what? There are a lot of choices to adopt specific cloud native infrastructure, but also application side. If you have some chance to take a look at the CNCF landscape, there are so many tools and awesome tools and projects. So I just should try to summarize the 6 point and main pillar. For example, the first one, the runtime. So cloud native runtime is not just application runtime, but also immutable infrastructure layer. So decades ago, we are looking forward to, we are familiar with using virtual machine, like a VMware, as a runtime environment. And there are some JVM or just a single Windows machine. But now, Kubernetes and container technology, immutable infrastructure is the default runtime environment. And then that runtime should be designed more container first strategy. So decades ago, yeah, you can run an install-based software. You can actually install any software based on agnostic or operating system, something like that. But we don't need to that feature any longer. So because we already packaging all application software based on container technology, Linux container. So now your runtime environment is pretty familiar with the container strategy. And then security. Maybe some people, maybe security guy is our roadblock to innovate our business problem, but that's not true actually. The security is all the most important part, and you can actually integrate your security tool or practice as a part of your DevOps platform, in a technical standpoint, even process standpoint. So security is always the matter of to succeed your multi-cloud and hybrid cloud strategy. And the cloud native software should be required observability. So we don't need to just a simple APM tool for cloud native application architecture or a platform. So we need more a discrete observability or monitoring tool. So for example, I'm pretty sure you already have some experience to use Prometheus or Grafana or Kyiv for your service meshing, tracing, and Jaeger. So point is, new cloud native software gives some extension or plugin or another feature to plug in that tools easily and simply. There's no need of maybe 10 pages installation guide. Just just pull your Jaeger container and just put into your application with some like a lazy consumption and production concept. And efficiency is another cloud native software matters. For example, so after COVID-19, we are more sensitive about the memory resource resources consumption. So small, fast, it occurs reducing your cost, which means that it's a really efficient way. So tiny memory footprint and small artifact size, or fast boot time, any application runtime like Java, Go, Python, Node.js, PHP, or whatever you need. But this is resource efficiency is one of the top agenda to consider new cloud software. The last thing is a little bit more methodology standpoint, like a DevSecOps and the DevApps rather than DevOps, because we have already such a great operation to Kubernetes or Amazon, Google, Microsoft, and Red Hat. A lot of companies already provide operation tools. So now we're more focused on application side and security, like a DevSecOps, DevApps. That's the 6th point to consider about cloud software adoption.
Yeah, by the way, our previous episode of Cloud Builders was exactly about DevSecOps, and yeah, there are tons of things to learn, and also I'd say it's sort of cultural change within teams to adopt this way of thinking when you don't outsource, hey, this security stuff, this is for our security team. No, folks, these days pretty much every developer, every technical person is the part of security story, right?
Exactly.
Also, so really great 6 points, and these days I feel that we have 7th one is coming. It's not official part of cloud native definition, but I see that more and more projects are going that way. And here I'm talking about serverless. What do you think about like state of serverless, about where and when to go for this technology, and how native to the cloud serverless is?
Yeah, that's a really good question, actually. It's a great question. You know what, so a lot of the CIO or the enterprise architect team lead are looking forward to what is the next in our cloud architecture, because we already have Kubernetes, we already have hybrid cloud, we already have Java, Go, Python, etc. So what should be next? Yeah, the answer is serverless function could be most prioritized your next agenda. So, but there's nothing new. I mean, you already have a lot of Microsoft's application, which means you can actually transfer existing Microsoft's application to serverless function anytime, anywhere, with the Kubernetes cluster specifically. And then the business perspective, this is a really important thing, because as a market trend analyzing, so let's say you have a 100 business application, but after last 6 months monitoring the utilization of that business functionality, maybe just 10% of the application service should be running on all the time. But the rest of 90% maybe is just running specific running time, like a subscription or Black Friday big sales. In the meantime, so what is the change or evolving our the resource management along with this seasonality or end user requirement or trend, something like that? So serverless and function, it could be based on Microsoft's architecture, but also you can run or hibernate that application, which means you can save your time and money and effort. But problem is, end user perspective, they don't feel inconvenient thing to use the business services. For example, okay, our application scaled down to 0, and then once the end user demand that service, it takes 10 seconds to spin up. It's a totally disaster. Everybody will be leave your business service. So that's why it's tiny application, fast runtime, just like I mentioned, one of the requirement in the cloud native software, exactly same way with this capability, right? So serverless and a function is the reason why we need to think about as the next generation a cloud native architecture. But also when we have a serverless function at the very beginning time, people just say, okay, it's a simple standalone application can be changed to serverless. But turns out any application can be changed to serverless. If we have the super fast response time and a small memory footprint and tiny the file size, right? And then you can integrate any backend application like a in-memory data grid or a backend messaging server or legacy another system. And then it's just maybe 1 second or maybe less than 1 second latency between that legacy system. When you call that serverless function, it just takes a half a second to start up. It's a normal the fault tolerance between that application throughput. So that's the next architecture of a serverless function, and there are a lot of opportunity chances to integrate serverless function with the existing your application. But there is some bottom line, like a container technology, Microsoft's application, and a fast runtime, and a small memory footprint, and a small size of file to reduce your network throughput.
Yeah, so serverless is such a large topic that I feel it might be the topic for our next Cloud Builders event. So we'll see. I see huge demand from the developers to learn more about that. And I personally feel that adopting serverless is really depend on how folks think about public clouds interoperability. I mean, when you have containers, you more or less freely interchange public clouds, right? But when you go for serverless, you start to depend more on a particular cloud provider. What do you think about that? What could you recommend folks to get rid of these thoughts, or maybe somehow make their serverless functions more interoperable? And maybe there are some open source projects in that area.
Yeah, that's a really good question. So yeah, the Amazon Lambda is actually a lot of people, and actually Amazon Lambda triggered the serverless era. So a lot of people think about first serverless equal Amazon Lambda. But now actually this Monday, the Amazon hosted the reInvent conference online, and there are very interesting stuff. So technically you can deploy your serverless application as Amazon Lambda. And then the Amazon Lambda serverless application can be deployed Google Cloud, just like portability. So even though you are thinking about the public cloud to run your serverless as a runtime, there are technically provide portability across public cloud for your serverless application workload. But also you can actually build up your serverless application on-prem, like a Kubernetes Knative project. This is a huge open source project to manage your serverless application based on Kubernetes functionality. Maybe it's really easy to jump into that technology if you already play with the Kubernetes experiences.
Yes, thanks for answering. And yeah, of course, all three major cloud providers, they have excellent services for running serverless. So it's definitely not only Amazon Lambda. In Azure, Microsoft has Azure Functions, which is also really interesting service to try. Let's finalize our discussion with your advice and recommendation to folks what to learn if you pick I don't know, top 3 technologies to learn in 2021. What could be your choice for folks to get into cloud native skills?
Yeah, so in general, I mean, I am also CNCF ambassador. So if you have a little bit more at the DevOps engineer or cloud native engineer, maybe it's a good starting point. Take a look at the CNCF project. I mean, graduate project rather than incubating project, because there are a lot of projects, more than 100 projects. So there's a starting point, like Kubernetes, Prometheus, and Jaeger, and then Cryo, and etc. And also, personally, I'm a little bit more a Java guy. So there are Quarkus project is more focused on Kubernetes native Java stack. So you can actually create a runnable Java application. You can run it and execute it by like a Golang without JVM. And it just takes maybe 10 milliseconds to start off. When you run that on top of JVM, it takes half a second, but it's maybe 100 times faster than any other Java application. So, also Java, maybe people saying, oh, it seems to be really heavy on running on Kubernetes or containerized technology. But so there are more and more enhanced and improved Java framework like a Quarkus and the other like a Micronaut, and there are a lot of new projects. So if you are a developer, and the new Java cloud stack could be great, interesting part for your next year. If you are working with the operation team, yeah, the CNCF project, and just try to contribute to that project, even tester or just open the file on issue or add a command. We are more than happy to your participation.
Awesome. Great advice, great recommendation. Thank you very much, Daniel, for being with us, and have a great day. You are in Boston, right? So it's still daytime for you. Okay, Daniel, bye-bye.
Yeah, thanks for having me, and have a good rest of the day, and keep you safe. Thank you. Talk to you later, Max.
Yeah. Okay, folks, so we are at the end of our event. I hope you enjoyed this. And I feel that we need to say proper kudos to the sponsoring company which supported this event. And this is Intellias, the company where our special guest is working. You remember the interview with Roman. They are full cycle software development service with offices in Kyiv, Lviv, Odessa, Kharkiv, Ivano-Frankivsk, and Krakow, with local presence in Berlin. Also, Intellias has more than 17 years of experience in assembling and managing world-class engineering teams in Eastern Europe. And folks, you remember the topic of our interview with Roman, right? It was about cloud solution architects or solution architects in general. So they are looking for a new employee with this job title. So you will find all the details in the description to this stream. Contact this company and build your career to be a great cloud solution architect. On that, thank you very much. You will receive an email soon with some interesting links we and our guests mentioned today, and hope to see you on the next Cloud Builders. Maxim Salnikov was with you. Bye-bye.